Jai Hind. Myself Nidhi Singh. I am assistant professor in Akgec Engineering College. Today I am going to discuss the solution that is for the semester 1 theory exam 2023-24 for the fundamentals of electrical engineering. Subject code is BEE101. So this is the part 5th. Previously I have discussed the part A, part B, and in this the remaining questions of part C we will discuss in this lecture. So let's start with the question number 6B. So question number 6B is, why single phase induction motor is not self-starting? What are the methods of starting? Explain any one of them. So this question is divided into 3 parts. The first part you have to explain why the induction motor is not self-starting. Then the second part you have to write the methods of starting the single phase motor, and in the third part you have to explain any one method for starting the single phase induction motor, right? So first we will see that why single phase induction motor is not self starting. First we will answer for this part. So why single phase induction motor is not self starting, we can explain it by using the double revolving field theory. And by this double revolving field theory, we can consider the two components of the stator flux, right? So we can so now consider the two component of the stator flux, each having magnitude half of maximum magnitude of stator flux. So if the magnitude maximum magnitude is 5 m, so each component will have the magnitude half of this, so 5 m by 2, right? So and both these components are rotating in opposite directions at the synchronous speed, that is ns, which is dependent on the frequency and stator pole, because we know that ns is equal to 120 f by p. So it is depending upon the frequency and it is depending upon the number of pole. So now if suppose phi f is forward component which is rotating in anti-clockwise direction, and phi b is the backward component rotating in clockwise direction, so the resultant of these two components at any instant will gives the instantaneous value of the stator flux at the instant. So resultant of these two is the original stator flux, right? So for example, here we have taken this is phi b and this is phi f. They both are in opposite direction and the angle is 0 degree. So here they both will cancel out each other and the resultant will be equal to 0. And if we now if both of them has angle 90 degree, so here we can see that both are in the same direction. So both these components will get added and you will get the maximum value, right? So similarly, if you plot for this, you will again get the original stator flux. So now both the components, they are rotating and hence they will cut by the rotor conductors, right? As both the component, that is both the component means backward component and the forward component. These both components are rotating in opposite direction and they will cut by the rotor conductors. So what will happen if they cut by the rotor conductor? So due to cutting of flux, what will happen? EMF will get induced in the rotor, right? According to Faraday's law. So now next, what will happen? So now because of this EMF, this will circulate the rotor current, right? So now when the current will start flowing in the rotor, what will happen? The rotor current will produce the rotor flux, right? So now the rotor current will produce the rotor flux. Then this flux will interact with the forward component to produce torque in one particular direction, say anti-clockwise direction, right? And while the rotor flux which interacts with the backward component to produce a torque, now say this is in the clockwise direction. So now the two torque are getting produced, one in the anti-clockwise direction and other is in the clockwise direction. So if anti-clockwise torque is positive, so we will consider clockwise torque as negative. So what will happen? So at start, these two torque are equal in magnitude but they are opposite in direction. The torque, they are opposite in direction, but the magnitudes are same. So each torque will tries to rotate the rotor in its own direction, right? Thus, net torque which will be experienced by the rotor is 0 at start. And hence, the single phase induction motors are not self-starting. So, this is how we can explain that why the single phase induction motor is not self-starting. So, this is the answer for the first part. Now, the second part, what are the different starting methods? So, different starting methods are a split phase induction motor, then capacitor start induction motor, then capacitor start capacitor run induction motor, then shaded pole induction motor. These are the 4 starting methods for the single phase induction motor. Now, coming to the third part. The third part is explain any one of them. So, we will explain the split phase induction motor, right? So, in a split phase induction motor, so in addition to this main winding, we have main winding, or we can say a running winding, we have a one auxiliary winding or starting winding, right? So, in addition to this main winding or running winding, a single phase induction motor stator carries another winding which is called auxiliary winding or starting winding. So, this is the extra winding which we have added in this, right? So, the auxiliary winding, these carries a series resistance such that its impedance is highly resistive in nature, and the main winding is inductive in nature. So, the auxiliary winding, we have make this winding more resistive, and the main winding is more inductive, right? So, the main purpose is to develop the rotating magnetic field. Rotating magnetic field, to develop a rotating magnetic field, at least we require 2 fluxes. So, that is why we have splitted this current in 2 parts, right? Okay. So, now let this IM, this is the current through the main winding, this IM is current through the main winding, and this IST is the current through the auxiliary winding. So, now we know that as main winding is inductive, so current will lag voltage by V by a large angle phi m, because this is not purely inductive, but this is more inductive, right? And IST is almost will be in phase with V as auxiliary winding is highly resistive. So, if we draw the phasor, so for drawing the phasor, first we will take this V as a reference line. So, phasor diagram is drawn here, but I will draw it again to explain this phasor diagram. So, we have taken V this as a reference. Then next we have to draw the IM. As we know that IM is through the main winding, and the main winding is more inductive, right? So, in inductive, what happened? This current will lag this V by some angle, right? So, here we will draw IM here, and the angle which we have taken is phi m, right? Then IST, what is this IST? This will be in almost in phase with V, because this is more resistive, right? And this IST is current through the auxiliary winding. So, IST is through the more resistive. So, I and V will be almost in phase with the V. So, here this is IST, right? And we know that this IM and IST. So, this I is equal to IM plus IST. The phasor addition of IM and IST. IST means in the starting winding. So, IM plus IST will be equal to I. So, if you draw the resultant, so you will draw the line which should be parallel to this, and you will draw the line which should be parallel to this line, and if you join, you will get this line as I, right? So, this will be the I, and the angle between IST and IM is alpha, okay? So, this is how you will draw the phasor diagram, okay? So, there exists a phase difference phase difference of alpha between the 2 currents, and hence between the 2 fluxes produced by the 2 currents. So, these are the 2 current, and the phase difference is alpha. So, the flux which will be developed by these 2 current will have a phase difference of this alpha only, and the starting torque depends upon this alpha. The more the alpha, the more the starting torque you will get. So, the resultant of this two flux is nothing but the rotating magnetic field, and due to this the starting torque which acts only in one direction is produced, and by using this you can start your single phase induction motor, right. So, this is the answer for the last part. Okay, now the auxiliary winding has a centrifugal switch in series with it, as you have seen in the circuit diagram. So, when motor gather a speed up to 75 to 80% of the synchronous speed, centrifugal switch gets opened mechanically, and in running condition auxiliary winding remains out of the circuit, right. So, auxiliary winding is only to start the motor. So, when motor achieves this much speed, it automatically get disconnected from the circuit. So, motor runs only on stator winding. So, auxiliary winding is designed for short time use, while the main winding is designed for continuous use. As the current IM and IST are splitted from each other by angle alpha at start, the motor is commonly called split phase motor. So, that is why it is called split phase motor, because we are splitting the phases, right. Okay. So, this is the complete answer. Now, coming to the next question. Explain the following with neat and label diagram. First is the earth leakage circuit breaker and the second is miniature circuit breaker. So, first we will explain earth leakage circuit breaker. So, earth leakage circuit breaker, it is a device that provides protection against earth leakage, and these are of two types. The first is current operated earth leakage circuit breaker. The second is voltage operated earth leakage circuit breaker. So, now what is the current operated earth leakage circuit breaker? It is used when the product of the operating current in amperes and the earth loop impedance in ohms, but does not, it should not exceed 40. So, such circuit breaker is used where consumer earthing terminal is connected to a suitable earth electrode, right. So, in this, this is the current operated earth circuit breaker diagram. So, in this current operated earth circuit breaker is applied to a 3-phase 3-wire circuit, right. So, in a normal condition there is no earth leakage. The algebraic sum of the current in the 3 coils, these are the 3 coils of the current transformer is 0, and no current flows through the trip coil. Here this is the trip coil, so no current will flow through this trip coil. So, in case of any earth leakage, the current are unbalanced. So, current will get unbalanced in these 3, and what will happen because of this? The trip coil is energized. Now, this trip coil will get energized, and thus the circuit breakers trip. So, this circuit breaker will get tripped. Okay. Then the next is voltage operated earth leakage circuit breaker, and this is the diagram for this voltage operated ELCB, and it is suitable for use when the earth loop impedance exceeds the values applicable to fuses or excess current circuit breaker or to current operated earth leakage circuit breaker. So, when the voltage between the earth continuity conductor and earth electrode rises to sufficient value, the trip coil will carry the required current to trip the circuit breaker. With such circuit breaker, the earthing lead between the trip coil and the earth electrode must be insulated, and in addition, the earth electrode must be placed outside the resistance area of any other parallel earth which may exist. So, the next part you have to explain the MCB, that is miniature circuit breaker. This is an automatically operated electrical switch designed to protect electrical circuits from overcurrent, which can result from short circuits or overload. So, the main features of these MCBs is first, overload and short circuit protection. It will trip the circuit when excessive current flows. The second feature is automatic operation, reset manually after tripping. Then faster response, it provides quicker reaction compared to fuses. then has a longer lifespan. Like fuses, MCB can be reset and reused. Then different ratings and types, these are available for various current capacities and applications. Now coming to the working principle of this MCB. So in this, when the current overflow across the MCB, or you can say miniature circuit breaker, the bimetallic strip, here it is a bimetallic strip. So this bimetallic strip, it will get heated and this will deflects by bending. So here in the second diagram, you can see that this bimetallic strip is bended. So when this bimetallic strip get bended, the deflection of this bimetallic strip, this will release the latch, right? The release the latch, so contact is open. So the latch causes the MCB to turn off by stopping the current flow in the circuit, and this process helps safeguard the appliances, or we can say devices, from the hazards of overload or overcurrent. And to restart the current flow, MCB must be turned on manually. So we can turn on these MCBs manually, right? Now coming to the last question, that is question number 7B. This is, what is the difference between earthing and grounding? Also discuss different methods of earthing. So this question is in two parts. In the first part, the difference between earthing and grounding is asked, and in the second part, you have to discuss different methods of earthing. So now let us see the difference between earthing and grounding. So both earthing and grounding, they refer to connecting electrical system to the earth for safety, but there are some differences. So if we see the definition of earthing and grounding, we can see that connecting the non-current carrying part, like the body of equipment, to the earth is called the earthing, and grounding, connecting the current carrying part, that is neutral of the system, to the ground, is called the grounding. What is the purpose? The purpose is to prevent electric shock to human by discharging leakage current. And the purpose of grounding is to provide the reference voltage for electrical system and stabilizes the circuit, right? Now the connection point, they are connected to the earth pit through the electrodes, right? They are connected to the neutral of the system, which is grounded. Then protection against the electrical shock to personnel, and this is protection against the over voltage instability and short circuits. Then they are used in electrical appliances, machines, transformer bodies, metal enclosures. They are used in power system, substations and electrical distributions network. Then example, like metal body of washing machine or refrigerator is earthed to avoid shock. Here neutral of power supply is grounded to maintain voltage stability, right? So these are the difference between earthing and grounding. Now coming to the various methods of earthing. So first method is strip or wire earthing, right? So this is one type of earthing, and in this system of earthing, the strip electrodes of cross section not less than 25 mm into 1.6 mm if of copper, and 25 mm into 4 mm if of galvanized iron or steel, and they are buried in horizontal trenches of minimum depth of 0.5 meter. If round conductors are used, their cross sectional area shall not be smaller than the 3.0 mm square if of copper, and 6 mm square if of galvanized iron or steel. The length of buried conductor shall be sufficient to give the required earth resistance. It shall, however, be not less than 15 meters. The electrode shall be as widely distributed as possible, preferably if in a single straight or circular trench, or in a number of trenches radiating from a point. If conditions require use of more than one strip, they shall be laid either in parallel trenches or in radial trenches. And this type of earthing is used at places which have rocky soil earth bed, because at such places excavations work of plate earthing is difficult. Then the second type of earthing is the rod earthing, and in this system of earthing 12.5 mm diameter solid rod of copper or 16 mm diameter solid rod of galvanized iron or steel or hollow section 25 mm GI pipes of length not less than 2.5 meters are driven vertically into the earth either manually or by pneumatic hammer. And in order to increase the embedded length of electrodes under the ground, which is sometimes necessary to reduce the earth resistance to desired value, more than one rod sections are hammered one above the other. And this system of earthing is suitable for areas which are sandy in character. And this system of earthing is very cheap as no excavation work is involved in this. Now the next is the pipe earthing. So pipe earthing is best form of earthing. It is cheap in system of earthing as GI pipe of 38 mm diameter and 2 meters length is embedded vertically in ground to work as earth electrode. But the depth, it depends on the soil condition. So wire is embedded up to the wet soil. The earth wire is fastened to the top section of the pipe with nut and bolts. The pit area around the pipe is filled with salt and coal mixture for improving soil conditions and efficiency of earthing system. It can have heavy leakage current for same electrode size in comparison to plate earthing. The earth wire connection with the GI pipe being above the ground level can be checked for carrying out continuously test as when desired when it is difficult for plate earthing. And in summer season, to have effective earthing, 3 or 4 buckets of water is put through the funnel for better continuity of earthing. Then the next is the plate earthing. This is the type of earthing, and this is commonly this is another common system of earthing. And in plate earthing, an earthing plate either of copper of dimension 60 centimeter into 60 into 3 mm or of galvanized iron of dimension 60 into 60 into 6 mm is buried into the ground, as you can see here, with its face vertical at the depth of not less than 3 meter from the ground level. The earth plate is embedded in alternate layer of coke and salt for a minimum thickness of 15 centimeter. And the earth wire, GI wire or GI plate earthing or copper wire or copper plate earthing is securely bolted to an earth plate with the help of a bolt, nut and washer made of material of that of earth plate, made of copper in case of copper plate earthing and of galvanized iron in case of GI plate earthing. So this is the required answer for the last question, the different types of earthing. And this is the last lecture for this AKTU semester 1 2023-24 question paper solution. Thank you. Jai Hind. And these are the references for the completion of this video lecture. Thank you. Jai Hind.